Today on the bench we have a Cobra 32 XLR. Probably hard to tell by looking at the radio itself, but there's the faceplate for it. Customer sent this in with another radio. I think one of them was given to him and one of them he's had, I believe. I had to read the note again, but they both pretty much, I think one of them didn't work when he got it, and the other one, actually I think it was this one, originally used to work, and it's just slowly died. So, as I often say, old radios, the most common thing you're going to find in an old radio, CCS, crappy cap syndrome. And this radio apparently was absolutely no different. And yes, I do notice there's one gray capacitor there I do have to change. I noticed that a little while ago before I tore the front of the faceplate apart. I gotta replace that. I missed that one because I had the radio standing up on its side when I do the cap job and missed that one. So yeah, I gotta get that little gray guy out of there. So when you see this radio later put back together and turned on, you'll see that'll be a new one. But in any case, so I recapped it with the exception of that one I missed. I did not even turn it on when I first got it. I've just gotten to that point. I don't even bother. When people say, yeah, it's been dying for a while, or things are starting to get worse, it's usually caps people. People, oh, well, why do you change the caps? How do you know they're bad? Well, this is another, and I see this so often, prime example. Didn't even turn it on, changed the caps, radio works fine. Now, don't get me wrong, it needs an alignment, it's an old radio, but just replacing the caps repaired the radio. I didn't need any test equipment. So, if you have a radio like this and you feel confident that you can do stuff like, electrolytic capacitor replacements, have at it. And actually, the 32 XLR is a good candidate for that, because it's not an overly complicated radio. It's fairly easy to do the cap job on yourself. And there's not a large amount of values in radio. There's only, 1, 3.3, 10, 33, 1, 3.3, 10, 33, 100, and 2000s right there that I always upgrade in value. So that's it. There's, 6 values of capacitors. So it's not like you need a huge parts cabinet full of 20 or 30 different values of capacitors. Literally, 6 values is all they use, which makes it nice because I need when I'm doing it, because that's less drawers I need to set on the bench. But, so, like I said, I got the cap job done, cleaned the circuit board, because yes, this is back in the day when they really loved gooping up the boards with the soldering flux, so it's really hard to see anything. It's one of those things you always want to make sure you inspect all the solder connections, not so much yours, you're doing them obviously, hopefully you're good with your soldering practices, but I need to inspect all the solder traces because it could have bad solder connections. But yeah, there's so much flux residue on a lot of these radios back then when they used to make these things that you just can't see the circuit traces. So break out your bottle of isopropyl alcohol and have a good scrub down with it. But it's all cleaned off now. You can see nice and shiny. You will need to lift this shield board. This is just a shield. That's all it is. They didn't use a metal plate like they do in pretty much almost most radios made after this one. This was a early, rather early radio. But yeah, just remove, I usually just lift that one wire off there, then you can just fold the board back, because if you're replacing the electrolytic caps, there are a bunch of connections underneath of this shield you'll have to get to. But yeah, cleaned it off, everything looked fine, powered it up, and it worked. So, yep, it was definitely CCS, or crappy cap syndrome. But yes, it had crunchy, scratchy controls. Oh my god, yeah, it would just and you'd flip switches, and yeah, it just sounded like shit. So I wanted to start the video here so I could show it while it was still taken apart. This is not one of those radios where you can just remove the covers, grab your can of deoxit, go psh, psh, and give the controls a twist and the knobs a flip, and you're done. Yeah, it's not quite that simple, unfortunately. Everything mounts to a circuit board in this radio. Okay, so as you can see, you can only get to the back side of one control. That's it. You could get some cleaner in there to that one, but that's pretty much it without dismantling the radio. So what you need to do is take the nuts off of all the control shafts, 2 screws on each side, hold this front structure on. Now, to get the faceplate off, of course, pull the knobs off, but you don't actually have to remove the screws because you can see the ears right there. They're slotted, so just loosen the 2 screws on top, 2 screws on the other side there, and you'll be able to slide the faceplate off. And there's 3 additional screws. You'll find, actually, you can see the green residue from the Loctite. There's 3 screws, one there, there, and there, that go into the switches and hold this front structure on. But once you get those 4 screws off then on the side, you can pull this out and pry. It's not so much pry, but pull this board out. Then you can get in there and clean it up. So that's what it looks like. If you ever have, if you have one of these, and you have real scratchy and intermittent controls, that's how you get it out. It's fairly simple, just a couple screws, so nothing more than 2 screwdrivers, a P1, a P2, and a 10mm nut driver. You'll have her cracked apart in no time, and you can get in there and do a little bit of cleaning. So these are now clean. I've already done them. I can put this back together, get that cap changed, do the alignment on it, and I'll be back to see how well this thing actually works. Okay, so I've got her all back together with the exception of putting the bottom cover on, but it's up and running. The transceiver alignment's been done to it, and yes, the one little capacitor that I missed earlier has been replaced. Actually, when I was getting ready to put the faceplate back on the radio, I was like, oh man, it's a shame this thing looks kind of screwed up. Not the bezel, but the actual faceplate, the aluminum faceplate. And that's when it dawned on me, it still had the original protective sticker on there, and it was starting to disintegrate. It took about, I don't know, 15-20 minutes and whatever's left of that fingernail to get that thing off of there. Oh my God, was it ever stuck on there. That's why I often tell people, if you have a radio you plan on keeping for a long time, I know people think it's a good idea, leaving that protective film on there, that sticker that they put on there, the transparent sticker that was on there originally when they punched the holes out, but yeah, they only last so long, and they start to dry out, and it can be a pain in the butt to get it off. I literally, when I removed that, when it came off in little tiny just fragments, I literally had to crumble the whole thing apart. I tried spraying some vinyl off on there. That's a vinyl decal removing fluid. That didn't do anything for it. I tried a little bit of Goo Gone. That might have softened it a little bit, but yeah, it was mainly just a lot of scratching. So actually, that cleaned up really nice. The faceplate, it looks brand new now. Just as good as they get. Yeah, you definitely, like I said, it's another thing you want to get those stickers off, because when they start to disintegrate, they'll start to shrivel up sometimes, and you'll see air bubbles starting to form under it. What happens if you let that happen is moisture can get in behind that sticker then, anywhere where there's an air pocket. And the faceplate, where if with no sticker on it, you might get a little bit of color change over the decades of the aluminum as the aluminum slightly oxidizes. But you'll never notice it because it's even across the entire faceplate. I'm not talking about white crusty oxidation, just a really light film on there, but you'll never notice that. Where if you leave that sticker on there with those air bubbles, when that decal starts to kind of shrivel up a little bit, when you eventually do remove it, you're basically screwed then. You'll end up with white streaks everywhere where air could get in behind that decal. And you can't polish it out, because if you try to polish the faceplate with any type of, polishing compound, you'll end up taking the silk screening or the printing off of it. So, yeah, this one was caught just in time, because, yeah, it was starting to shrivel up and get air pockets under it. So, kind of fortunate. I was afraid that when I started to pull it off, I was gonna see some discoloration in the faceplate, but it actually cleaned up really, really nice. So, like I say, it's back together. Works good. Now, these are not power monsters on output power. A lot of people think, oh, the old radios, man, they put out so much more power than the new radios. Well, actually not. If you ever look at what they use for driver and final transistors in a lot of the older, early solid-state radios, they weren't high power. They just sounded good, though. That was the thing. They had more punch. The audio frequency response of the radio on transmit was just a lot better than a lot of your modern radios, and it sounded more punchy, even though the radio is actually producing a little bit less power than, or in some cases, a lot less power than a modern radio. they just sounded better, and that's why. It had more to do with the audio than it does the actual output power. But this one's doing well within spec. Receives really good on this. Actually, I have it hooked up to the communications test set, and it's doing just a hair below 12 dB SYNAD. Let me bump it up a little. Oh, actually, right around there. Yeah, I'd bump it up. Say 0.13 microvolts for 12 dB SYNAD. So 0.13 microvolts, and that's a SYNAD measurement right there. So, and that is minus 124.7 dBm. So really good receive. AM only radio, but they're nice radios. They have a fairly good filtering circuit in them. And probably a little bit better designed as far as the receiver circuitries in these than some of the more modern radios, for AM-only radios. But one of the things that's kind of I don't want to say it's unique, because actually this chassis, and you can probably tell by all the empty holes in this radio, this board was used in several other radios. And of course, they all are going to have the same synthesizer circuit, and like I said, I don't want to call it unique, because like I say, this board was used in more than one radio and in different configurations. But this was a very early PLL synthesizer circuit. So a lot of you are probably looking in here and going, aha, there's the PLL. No, not really. They call it a dual PLL in these. It doesn't really have what I would refer to as a PLL chip. They're accomplishing the PLL with multiple ICs. So actually, if you look down in here, there's an IC standing up there. There's one standing up here. And these are SIP or single inline package styles. There's actually another one here, and then you can see here's the normal package that you're used to looking at for like PLL chips, which is a DIP or dual inline package. But actually, let me just grab the schematic. It would be easier to show you on the schematic what I'm talking about than sitting here blabbering about it and you don't know what the heck I'm talking about here. So here's actually a factory schematic. So you can see there's actually a total of 4 ICs here. There's a TC5080, there's 2 TC5081s, and then there's a TC5082. Yeah, they just all kind of go in order. They were all kind of made to work around each other. So what they call, like I say, they have a VCO and a VCM in these. Now, a lot of you are probably familiar with the VCO. That's a voltage-controlled oscillator. So one of the PLLs is used for, or at least what they call a PLL, is used for the voltage-controlled oscillator, phase comparator, and one of the crystal-controlled oscillators. The other circuit is used for the voltage-controlled multivibrator, or a VCM. That's where, like I say, this is kind of different. It's an early PLL circuit, but that was also used for a phase comparator and a digital divider. So the VCM is a free-running oscillator, and the frequency on that can actually shift with the change in DC control voltage applied to it. That's why they call it a, the name kind of gives it away, voltage-controlled multivibrator. So it kind of gives away what it does. But yeah, so this is the PLL. Like I say, they call it dual PLLs. Yeah, that's kind of a stretch, because neither one of what they're calling a PLL to me is a true PLL circuit. The PLL is actually kind of more or less made up of all the ICs, and it also kind of incorporates the VCO into the same circuit. Like I say, it was just it was a unique design they used back then. It didn't last very long because semiconductor manufacturers quickly came out with what I call the one-chip wonders, or a PLL in a single IC. So, and you can see here, here's your channel selector switch. So here's all the programming that goes into your IC here. And another interesting thing you can do with this radio, this has scan features. So if we look at the front, actually, let's see if that speaker wires are going to be long enough. Get her tilted up here so you can see it says off, scan, and hold. So if you put it in scan and have the squelch turned up, what it will do is whatever channel you have the channel selector turned to on the display, so let's say channel 19, if you flip it into scan, turn the squelch up, it will scan between channel 19 and 9. If you change the channel selector to say channel 24, it'll scan between channel 9 and 24. But you can change that. You can change the channel 9, and that was actually a factory actually has that in their service literature how to do that, and that's accomplished actually with these diodes right here, or adding or subtracting diodes. So what you're doing is when you flip that circuit in, you're applying power here through these diodes, through this diode network right here, and you're basically replacing the channel selector switch. In a nutshell, that's what you're doing. Channel selector switch goes away. One transistor here applies voltage to the channel selector switch. The other one applies to this diode network. So basically, these transistors are turning on and off. So when it's on, it's scanning the channel that's your channel selector switch is set to. That transistor will be turned on, and vice versa. When it's on the channel 9, this one will be off, and this one will be turned on, and it's applying voltage. But it's using that, so it's flipping between either using the channel selector to program or a diode combination. Now, the nice thing is, you can change that. So let's say you don't want to scan channel 9, because honestly, yeah, channel 9 is not really used as an emergency channel anymore. It's still supposed to be, but I don't think I've heard anything on channel 9 emergency related for decades. Everybody's got a cell phone nowadays. But, so you can actually change that, and actually let me grab over here, it's actually in the factory service manual. Diode, yeah, right there. So here's the actual combination, and that's all you do. You just pick. So if you wanted channel 14 to be your home channel, you'd install diodes at these locations, to these pins on IC10. So that's all you're doing. Pick what channel you want. So as the radio sits right now, you can see there's a diode attached to pin 2, pin 3, pin 5, and pin 8. And if we look down here, we can see pin 2, pin 3, pin 5, and way over here, pin 8. So that's all you're doing. So you wanted to change channels, you'd either add or remove diodes in here, and the holes are already down here in the radio form. It's just a combination of diodes. So that's kind of nice. So you could, if you want to monitor channel 19 and I don't know 24, or channel 12 or 36 or whatever might happen to be a home channel, but you want to monitor two channels, you can change this diode combination to set one channel permanently, and then you use the channel selector on the radio to select your other channel, and it will sit there and scan between those two channels. So that's an early way that they achieved scanning on these radios. And other radios have that, actually use the diode switching circuit. They're actually switching between the channel selector or diodes that are used to actually program the PLL circuitry, but that's how that actually works. So there you go. So like I say, it's good receiving radio, transmits good, sounds good. Ready to put the covers back on and give it a final clean off here, and we'll be ready to head back to the customer. Actually, I need to do another radio for me. Actually, there was two radios in the box he sent, so I also have a Royce Model 609 to do now. It's supposed to be dead as well. And just like this one, I'll do the same thing. Recap the radio and take it from there. Just like I often say, recap your radios first. If it's having problems, it's an old radio. You can be almost 110% guaranteed it's going to have bad caps. They may not have failed completely, but your receive sensitivity is probably a little bit low. Your transmits power is probably a little bit low. Your audio is probably partially distorted. That's because all those electrolytic capacitors in there, they're drying out and slowly starting to short out. They haven't become a dead short yet, but they're causing problems. It just may not be glaringly obvious yet. But a lot of times when you replace all those electrolytic capacitors, you turn your radio back on, you'll be like, oh my God. Even if the radio was working before, you'll turn it back on and you go, holy shit, man, this thing hasn't sounded this good in years. And that's all it was. Bad caps. You just didn't realize, because they don't just, well, they can go bad in an instant, but usually they go bad over time. They'll just slowly degrade. You don't even realize it's happening over years and decades as the caps are slowly shorting out more and more and more. performance in one area of the radio is slowly degrading, but it happens over such a long time, you don't really notice it. You get used to it. But when you recap the radio, and that's all you do, not even before you even do an alignment, just recap the radio and turn it back on, a lot of times you'll notice, holy crap, man, this thing sounds great. Your output power picks up, the modulation picks up, your receive audio sounds so much better, sensitivity picks up, and you haven't even done any adjustments yet. So, yeah, you definitely want to watch out for CCS, or what I call crappy cap syndrome. So let me get this one buttoned back up, finish cleaning it up. I'll get the Royce on the bench, and I'll probably do a separate video on that one.